Hello, welcome to Sparking STEM. This session has got the most sparkly, beautiful chemical reaction. We're going to do a precipitate of lead nitrate, which I have a solution of here. It's quite a nasty toxic chemical, so I've done lots of health and safety things to do this very carefully. Please do not try it at home. So lead nitrate, PbNO3. I've got a solution of it here. It's quite difficult to get into solution because it's not very soluble, so you have to heat it up. And I've got another solution here of potassium iodide, Ki. That's much easier to get into solution because it's much more soluble. Now I'm going to do most of this outside and I'm going to need to do some heating, so I'll take these outside. We're going to add the potassium iodide solution to the lead nitrate solution, and you'll see, before I do it, just take a quick note, look at these very carefully. You'll see that they are both transparent and colourless solutions, just like water. They have no colour and the light can get straight through them. But look what happens when I add the potassium iodide to the lead nitrate. Let's go outside. And here it is. Look what's happening as I add the potassium iodide to the lead nitrate solutions. They were both transparent and colourless, remember, but look, a chemical reaction is happening, and the whole definition of a chemical reaction is that a new substance is being formed. The new substance that's being formed here is lead iodide. Now, lead iodide is this bright yellow solid crystal that doesn't dissolve very easily at room temperature. If I add lots of it, you can see the solution goes really deep, dark, opaque yellow and has this lovely iridescent shimmering quality because of the crystals reflecting the light. But because we're not working at a high temperature, those crystals are a solid. It's very hard for them to dissolve into the solution, and so you can see them swirling around like this. Now this is pretty beautiful to watch just as it is, but this isn't the full golden rain experiment. What we need to do to see the full golden rain effect is to heat up this solution so that those crystals of lead iodide dissolve, because they become much more soluble at higher temperatures, and then, well, let's see what happens. So here it is. I've placed it on a bit of a homemade hot plate, really. We're still outside. You can see some smoke coming off there. And that's not from the chemical reaction, that's just from something on the hot plate. But as it is warming up, the temperature of the solution is increasing, obviously. The particles are getting more kinetic energy, and the lead iodide crystals, those solid yellow crystals, are starting to dissolve into the solution. Now it takes quite a long time for it to get back to a completely colourless state, so I'm going to speed up this recording here, and you can hopefully see that over this duration as we heat it, the solution is gradually becoming more and more colourless. It's losing that yellow golden colour as those lead iodide crystals dissolve. I'm giving a little shake every now and again, and over time it gradually goes back to being colourless. And I've skipped ahead here because that really did take quite a long time. But this is what we've ended up with. We're back to this sort of colourless, transparent solution, similar to the ones that we had right at the beginning. And it's starting to cool down. It was really quite hot, around 100 degrees centigrade. And I'm leaving it now to cool down. It's going to gradually lose that heat energy. And as it does so, those lead iodide crystals lose their solubility as well. It's harder for them to remain dissolved into the solution. Now you might just be able to start seeing here what looks like little tiny specks of shining light flickering around as these lead iodide crystals recrystallize, turn back into crystals, these golden yellow crystals, but this time because it's recrystallizing, they come back as a bigger hexagonal crystal, little tiny thin plates of lead iodide with a hexagonal shape, a bit like snowflakes if you like. Now I'm going to speed up the video a bit here so that you can see what happens, because this takes quite a long time to happen. As the solution loses heat energy and cools down, the lead iodide crystals form. We can call this a precipitation. A precipitate is just when a solid is forming within a liquid, and you can see the precipitate here is these crystals of lead iodide. And as it cools, more and more of these start to form until it looks like it's raining with these lovely golden crystals. Now, the other thing you can call this chemical reaction is a double displacement reaction, because what's happened is that the two metals, the lead and the potassium that were in our reactants, have basically swapped places. They've displaced each other and formed two new compounds, the lead iodide, or lead 2 iodide, and potassium nitrate. The lead iodide is the crystals, as we've mentioned, and the potassium nitrate is the solution in which they are precipitating. Now, it takes quite a few hours for this to cool down enough to get what you'll see at the end, but look at it, isn't it beautiful as they shimmer down and fall as our lead iodide golden rain. And this is what we end up with several hours later. All the lead iodide crystals have dropped to the bottom of our conical flask, and you can see they're still forming, they're still falling out of solution here and drifting down to the bottom. And so there it is. I really hope that you have enjoyed watching this beautiful, sparkly chemical reaction, the golden rain reaction, a precipitate of lead nitrate in potassium iodide. I'll leave you watching those beautiful sparkles for a moment. If I swirl them round, you can see as those little crystals catch the light. Thanks for watching.